All right, finally, tangent lines. When you have a polar curve and you want to find its tangent line, you have the same conundrum that you had with parametric curves in Cartesian or rectangular coordinates. The issue is finding the slope. Every line has equation in rectangular coordinates, mx plus b like this, or you can use point slope. Like this. And so if you know a point that the line goes through, you're fine. The difficulty then is finding the slope. M is the issue, and same thing as with parametric curves in general, that's dy dx. And we've already seen that this is dy dt over dx dt that I've agreed to write as y prime over x prime with you. So the only thing we have to do now is to consider that t is theta, so the parameter is the angle, and same as what we did with arc length, rewrite this formula for x equals r cosine theta and y equals r sine theta. So if that's what you have, then that means x prime will be r prime cosine theta by product rule, r times negative sine theta. So I'm going to put a negative here, product rule, and then y being r sine theta. There's not going to be any negatives this time. R prime sine theta plus r cosine theta by deriving the second. So when you try and do dy dx equals y prime over x prime now, you're simply writing r prime sine theta plus r cosine theta, all of that over r prime cosine theta minus r sine theta. You always have to be careful about whether or not this thing here is 0. So when r prime cosine theta minus r sine theta is different, is not equal to 0, then you're fine. But if it equals 0, then you might have some issues with vertical tangent lines and the like. So I'm not going to be talking about this, but you have to keep this in mind. All right, let's do an example of how to handle this. And this example is worded, maybe this is a little small. I'm going to read it with you in case you can't see well. You're finding the slope-intercept equation of the tangent line to the cardioid. So this is the line that you have, the equation of the cardioid. So I'm going to write it here just so you can see. The cardioid is this. And we're at the point where theta is pi over 3. So we don't have to plot this cardioid every time you have to do equations to do calculations with it. I'm going to plot it now again, just so you know what's going on. And this is the sort of upside down heart shape that we're talking about. Theta equals pi over 3 is whenever the point you're looking at makes this angle with the positive horizontal x-axis. So whenever this is pi over 3, you get this point right here. The line we're looking for is this line here. So just by the sketch, I can tell that the line has to have negative slope. And so I'm going to be using the formula we just came up with to find out the tangent line equation. Now, here's one thing that I think those problems don't emphasize enough. We're talking about a Cartesian equation. So most of the time, your problems are not going to be as obvious and sort of spell out that you're talking about the Cartesian equation. We're talking about equations in x and y. So the answer needs to be a tangent line equation. That's the usual type of equation we know. Y equals mx plus b because it's asked for slope-intercept, or y minus y1 equals m times x minus x1 if it doesn't say, or if it wants point slope form. That is not always spelled out, but you have to know in context that this is what the problem means. So I'm going to go ahead and just do that. I know that y is r sine theta. I need to find r prime, so that's r prime sine theta plus r cosine theta. So r prime is going to be cosine theta. Right, r prime is cosine theta right here because this is r. So this is what I get, plus, and r is 1 plus sine theta times the cosine of theta. And now that all derivatives are done with y, I can immediately plug in theta. I don't have to simplify things over here with thetas anymore because I already know the value of theta, so I might as well immediately say the cosine of pi over 3. Pi over 3 is 60 degrees, so that is 1/2 times square root 3 over 2 plus 1 plus square root 3 over 2 times 1/2 like this. So this is square root 3 over 4 plus 1/2 plus square root 3 over 4. So I get to combine these to get 2 times square root 3 over 4, which is just square root 3 over 2. And then this is just square root 3 plus 1, all of that over 2. So that's my y prime. Okay. Check to see if I haven't made any mistakes whenever I'm doing this too fast. It is likely that I'll be making mistakes. And then I'm going to go solve for x prime. You know, x, as you know, is r cosine theta. So x prime, when theta is the variable, will be r prime cosine theta minus r sine theta, because the derivative of cosine is negative sine. And again, r prime, looking up, is going to be cosine theta times cosine theta minus, and r will be 1 plus sine times sine. I could, if I wanted to, sort of expand this to get a sine squared, cosine squared, see if I can combine this into 1, but you can see that this negative is not going to let this happen. I'll get a cosine squared minus the sine squared, so it's not going to get into 1 anyway. I'm going to expand it just so you know that it doesn't happen. But again, like you did before, you could have immediately plugged in the value for theta. So now that you know, since you know going back, that theta is pi over 3 on the top there, you can just plug that in again. Pi over 3 is 60 degrees. The cosine of pi over 3 is going to be 1/2. And then the root 3 over 2 minus root 3 over 2 squared. So that for us will be 1/4 minus root 3 over 2 minus 3 over 4. And again, these you get to combine to get a negative 2 over 4 minus root 3 over 2, which is the same as negative 1/2 minus root 3 over 2, which I get to combine into the same fraction, 1 plus root 3 over 2 here. I have one big negative outside that applies to the whole thing. So then to finish it up, I wanted the slope of the tangent line, and that was dy dx, and that was y prime divided by x prime. So x prime, y prime was this, root 3 plus 1 over 2. All of that divided by negative 1 plus root 3 over 2. Again, the negative applies to the whole fraction, so I'm going to put it like right here. And dividing two fractions, repeat the first multiplied by the reciprocal of the other. And you get to cancel these to just get a negative 1. Now, you could have seen the negative 1 coming earlier. As you know, this is the same as this, and this is the same as this. So it's two equal numbers dividing each other, except for the negative that's outside. So it's just a negative 1 there. But either way, that is the m value. Now I need to find the x1 and y1 of the point to find my slope-intercept. Go back to what I have, right? So this is the equation that I'm looking for. Again, r is 1 plus sine theta. So I need to find x and y, but I also know that x is r cosine theta, and then y is r sine theta. I know cosine and sine of theta, so that means I also know r, so that means I also know x and y. So I'm going to go at the bottom here. Now that I've found the slope, I'm going to write this. Theta is pi over 3. Since r is 1 plus sine theta, r is 1 plus 1/2. Sorry, root 3 over 2. So that is r. And so that means x, which is r cosine theta, is going to be 1 plus root 3 over 2 times the cosine of root 3 over 2, which is now 1/2. Then I get to do this. This is 1/2 plus root 3 over 4. That's the x value of my point. And then y being r sine theta. So r was 1 plus root 3 over 2 times the sine of theta, which is root 3 over 2. So squaring like this gives me root 3 over 2 plus 3 over 4. So that is the y value. So the equation of the tangent line, if I make it slope point slope, it's y minus y1 mx minus x1. Forgot the equal sign right here in the middle. It's an equation, so it needs an equal sign every time. So that means y minus this whole value equals -1 times x minus this value. And all that's left for us to do is just do some algebra. I may have made a mistake somewhere in here, so you all feel free to let me know if I have. This is plus all this, because this negative and this negative cancel each other out. And if I go back to the problem, I believe it asked for slope-intercept equation, so I'm going to move everything over to the same side. This is going to go over that way, combining with this, and this is going to go over that way, combining with this. So I'll get that y equals -x. So this is positive 1/2 with a positive 3/4 now. So that's 2/4 plus 3/4. So that should be 5/4. And then that is a root 3 over 4. As I combine them here, root 3 over 4 plus root 3 over 2, it would be 2 root 3 over 4. So it is 3 root 3 over 4. So I believe that to be the correct equation. You can always use a graphing calculator to check. Let's see if I get to open this. Desmos graphing calculator. So r equals 1 plus, plus the sine of theta. So we get the nice cardioid. And now the equation of the tangent line, it was y equals -x plus 5/4. The slope seems fine. And then plus, it was 3 square root 3 divided by 4. And that is perfectly correct, being tangent at the points that we need it to be. So that's great.